We are looking at a supply and demand example, and we are looking at this example to look at the algebra. The example is that of barley farming, which is one of the easier examples from an economics course. In our first bullet point, we are told that the barley that the farmers are willing to supply is given by the equation P equals 1.9s minus 0.7. P represents the price per bushel, and S is the amount of barley in billions of bushels. Our second bullet point tells us that the barley that consumers are willing to purchase is given by P equals 2.8 minus 0.6D, where P is the price per bushel and D is the amount of barley in billions of bushels. Looking at these first two, I see that P stands for price in both equations. I see that S and D both represent the billions of bushels of barley. I see that S is used in the supply equation and D is used in the demand equation, but both represent barley. The final bullet point says that the equilibrium price is the price at which the quantity supplied is the same as the quantity demanded. We are asked to find the equilibrium price for barley. In that last bullet point, we see that the quantity supplied, which would be S, the billions of bushels supplied, is the same as the quantity demanded would be D. And so we have a concept for solving where supply, S, equals D. Our first two bullet points gave us formulas, but when I look at these formulas, they are not written in the form of S equals or D equals. So my first step to solve this problem is to take my formula and get it so that it is S equals or D equals, so I can use it to set it equal to the other formula. So from the first bullet point, P is equal to 1.9S minus 0.7. I want to get S by itself so that I know the equation for supply. To do that, I will add 0.7 to both sides. So I have P plus 0.7 is equal to 1.9S. And then I need to divide on both sides by 1.9 because division is the inverse of multiplication. You'll notice that I really am not simplifying because I do not have any like terms, but here these do cancel each other out, as up here these were inverses and canceled each other out. So I get S is equal to P plus 0.7 divided by 1.9. That's helpful to me because now I have a formula where I know what S, the supply, is represented by. I need the same thing for the demand, so I take the formula from the second bullet point. So P equals 2.8 minus 0.6D. When I'm solving the equation, I always have to undo any addition or subtraction first. Since this is a positive 2.8, I will be subtracting 2.8 from both sides. These will cancel. On this side, these are not like terms, so I can write the subtraction, but I can't actually do the math. Make sure you don't lose your negative. This was a negative 0.6D because it had been subtraction originally. Now, in order to get D all by itself, I do need to divide because these are multiplied. When I do that division, I include the negative so that the whole thing will cancel. So these guys cancel, and so I have D, the demand, is equal to the price minus 2.8 divided by negative 0.6. And so again, I have something that's very useful because I have a formula which represents demand. So going to that last bullet point, we were told supply should equal demand in order to find an equilibrium price. So instead of supply, I'm going to write the formula that represents supply, which is P plus 0.7 divided by 1.9. And set that equal to the formula for demand, which was P minus 2.8 divided by negative 0.6. Now I have a new equation. The equal sign there in the middle tells me that it is indeed an equation. In this equation, both sides are fractions, and when I have that scenario, I get to use what is called the cross product. So I'm going to multiply the tops and the bottoms of the fractions together to remove the fraction aspect. So I'm going to multiply going left to right first, so I'll have negative 0.6 parenthesis p plus 0.7 is equal to, and then I'll multiply again left to right going this way, top to bottom to top this time, 1.9 parenthesis p minus 2.8. So I no longer have fractions, but I do have to distribute because I have those parentheses that grouped the different numerators. So my distributive property means I multiply this one in front times each value that's inside my parentheses, and so I get negative 0.6p. Negative times a positive does equal a negative, so minus, and with the help of a calculator, 0.42. And then I have my equals. Again, I have to do the distributive property, so I have 1.9p equals, or excuse me, minus, because positive and negative will make a negative value, and again with the help of a calculator, 5.32. Now I would like to get like terms together. So in order to do that, I'm going to start with addition and subtraction. So I'm going to add 0.42 to both sides. That is a constant term, so I add it out here. So on the left-hand side, these cancel, and I'm left with negative 0.6p equals 1.9p. And I'm doing this on the calculator. Remember, this was a subtraction here, so negative 5.32 plus 0.42 gives me a value of 4.9. And that actually is a negative 4.9. You can just put the subtraction, or you can do what I did here, plus a negative. Either way will work. Next thing I want to do is move this p term over here. So I'm going to subtract 1.9p from both sides. So here, these guys cancel. This side, both of these are negative. I do that work on my calculator, and I have negative 2.5 p equal to negative 4.9. My last step is to try to get p all by itself, and I do that by dividing, because right now it's multiplied. Keep the negative, so I divide by negative 2.5. I do that on both sides, and I get p is equal to 1.96. So going back to my original problem, p is the price per bushel. So when I want to label this, it is money, and it would be $1.96 per bushel of barley. So what is the equilibrium price? That equilibrium price is $1.96 per bushel. The way that I found that was because the problem told me that in equilibrium price, supply will equal demand. I used the two formulas to get a supply formula and a demand formula, and then I set supply equal to demand. Quite a complicated equation. I used the cross product to get multiply. I used the distributive property. I got my constant terms together. I got my variable terms together. And finally, I divided on both sides to get my answer.